This is Algebra Lesson 10-4, Part 2, Applications of Quadratic Equations. Now, the other day we solved quadratic equations by factoring. Now we're going to look into the applications, in other words, word problems, how to set up the equations so that we can solve the equations. Many word problems can be solved by solving a quadratic equation. We're going to focus on writing and solving some that deal with quadratic equations. Let's say we have this first question. Suppose that a box has a base with a width of x and a length of x plus 3 and a height of 1 inch. It is cut from a square sheet of material with an area of 130 square inches. What are the dimensions of the box? Okay. So, basically, we have the box. It has a width of x, okay, and it has a length of x plus 3, so we already know those things. So I'm going to actually write those down because we already know those. The width equals x, and the length equals x plus 3. This box has that as a base. It's cut from a square sheet of material. So basically, we had a square sheet of material that looks something like this. It could be a rectangular piece of material. It actually should be a rectangular piece of material, not a square sheet of material. Okay. Basically, what happens is you cut the corners out of each edge of a box, like this. And you fold up along these new dotted lines, which I'll do in green. And you're going to fold the corners up like that, and that's your box. Okay? This box happens to have a length of x plus 3, that would be right here, and a width of x. Which means before we cut the pieces off, remember this was 1 inch here, 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 1 inch here. So now we have x plus 3 plus 2 extra inches, which would make this x plus 5. So this is now x plus 5. Again, with the width, it was x, but this new width is going to be x plus 2, because we're adding an inch from here to here. So those are the dimensions of my box. If you remember, the area equals length times width. Okay? So my length times my width has to equal my area. So length times width equals area. My original length, okay, is x plus 5, and my original width, put that in the width box. My original length is x plus 5, that's what this would be, and my original width is x plus 2. So my length, x plus 5, times my width, x plus 2, has to equal my total area, which is 130. So those are my dimensions. Now I don't need to multiply this together. Actually, yes, I do need to multiply this together. Excuse me. I do need to multiply this together because it's not set equal to 0. It's set equal to 130. So we'll distribute. We'll get x squared plus 5x plus 2x plus 10 equals 130. So if we simplify, x squared plus 7x plus 10 equals 130. Subtract the 130 from this side and put it on this side. That will give us x squared plus 7x minus 120 equals 0. So now we need a product of negative 120 with a sum of 7. So if we sit here and work on that a little bit, you should find out that that would be like, let's see here, positive 15 and negative 8, I believe. Yep, positive 15 and negative 8. So that will give me x plus 15 times x minus 8 equals 0. So x plus 15 equals 0, x minus 8 equals 0. So x can equal negative 15 or positive 8. Now let's think about this for a minute. Can I actually have a length that is a negative number? No, I cannot. This is where checking your answer might be a really good idea. Because even though negative 15 solves the equation of x plus 15 times x minus 8 equals 0, it doesn't solve our original equation because you cannot have a length that is negative. So therefore, this is what we call an extraneous answer. Solves the second part of our equation, doesn't really solve the original problem. So since you can't have a negative 15 for a length, x is equal to 8. So if x is equal to 8, okay, and I want my original width and my original length. My original width is 8, and I believe this is in inches. Let me check. Yep, it's in inches. So my original length is x plus 3, which is 8 plus 3, which is 11. So it asked us, the original question asked us, find the dimensions of the box. So our dimensions of the box is 8 by 11 by 1. The dimensions of the box are length is 11 inches, width is 8 inches, and height, a little depth if you like that, is 1 inch. And that's the 3 dimensions of our box. I wish the picture helped an awful lot on this particular problem. Let's get another one. The sum of a number and its square is 6. Find the number. Well, I'm going to let x equal my number, and it really doesn't matter. I'm going to let x equals the number. The sum of a number, sum means add, and its square, that means x squared, equals 6. The sum of a number and its square is 6. We literally just translated that word for word. It is not in the proper form. So we need to get it in ax squared plus bx plus c form. So this would be x squared plus x minus 6 equals 0. So we have to move the 6 to the side and move the x before the x squared, or the x squared before the x. So now I need a product of negative 6 with a sum of 1. So I'm thinking positive 3 and negative 2. So x plus 3 times x minus 2 equals 0. So x can equal negative 3 or x can equal 2. Then you might say, well, can we have both of those numbers? Well, let's check it out. The sum of a number and its square is 6. The sum of a number, negative 3, and its square, the square of negative 3 is 9. Negative 3 plus 9 is 6. That works. The square of a number 2, 2 squared is 4. Okay, 4 plus 2 is 6. That one works. They both check out, so our numbers are negative 3 and positive 2. The number is negative 3 or positive 2. It can be either one of those because both of those make a true equation. Let's look at number 3. A rectangular area is such that one side is 4 feet longer than the other, and the area is 5 square feet. Find the length and width. Okay, let's draw a picture. Pictures are worth 1,000 words. My case, probably 20. Rectangular area is such that one side is 4 feet longer than the other. Okay, so if this side is x, this side would be x plus 4. Okay, so x is one side, x plus 4 is the other side. Or I can say the width equals x and the length equals x plus 4. Always define your variables. Always, always, always. And the area is 5 square feet. Well, you should remember by now that length times width equals area. So x times x plus 4 equals 5. In order to solve this, we have to multiply it through first. So x squared plus 4x equals 5. That is not in the right form. So we'll have to subtract our 5 and move it to the other side. So we now have x squared plus 4x minus 5 equals 0. Now we need to factor this. I need two numbers whose product is negative 5 and whose sum is 4. So I'm thinking positive 5 and negative 1. So x plus 5, x minus 1 equals 0. So x can equal negative 5 or positive 1. Now let's think about this. Can we have a negative length? No, we cannot. So again, negative 5 gets crossed off. The negative number can't work because you can't have a negative length. Therefore, x can equal 1, so my width is 1, and I forgot my label, foot, and the length is 1 plus 4, which is 5 feet. The width is 1 foot, and the length is 5 feet. As you can see, you get pretty decent at these. They're not that hard to do. They're fairly straightforward problems. And now let's take a look at the problem of consecutive even and odd integers. We did that before. Okay, it says the product of two consecutive positive even integers is 24. Okay, two consecutive positive even. So I'm going to let x equal my first even, which means x plus 2 is my second even number. The product of them, every time up to this point we've always been doing sums. Now we're doing products. So x times x plus 2. The product of two consecutive positive even integers is 24. So x times x plus 2 is 24. If we distribute, we get x squared plus 2x equals 24. You have to get this in standard form, so subtract 24 from both sides. And you will get x squared plus 2x minus 24 equals 0. So I need a product. Okay, I'm just going to move this up here for a second. X squared plus 2x minus 24 equals 0. I need a product of negative 24 with a sum of 2. I'm thinking 6 and 4. Positive 6 and negative 4. So x plus 6, x minus 4 equals 0. So x plus 6 equals 0, x minus 4 equals 0. So x could equal negative 6 or positive 4. Which means if x equals negative 6, x plus 2 would have to equal negative 4. And if x equals 4, x plus 2 would equal 6. So our pairs of numbers are, your numbers are, okay, and if you look at this and go, wait a second. If you look here, it says positive even integers. So we can automatically get rid of any negative even integers because it says product positive. So we're only looking at these two answers right here. Okay, so my solution is the numbers are 4 and 6, because even though negative 4 and negative 6 works, because if I take negative 4 and I multiply that by negative 6 plus 2, because if you look at it, if you check negative 6 and negative 4, I'd have negative 6 parentheses negative 6 plus 2, okay, which would be negative 6 times negative 4, which would be a positive 24. Okay, but it says the product of two consecutive positive even integers. Those are negative even integers, so even though they make the product of 24, they don't fall into the category of being positive, so they don't work. Find the side of a square with an area of 81 square feet. Okay, it's a square, so let's draw a square. There's a square. What do we know about squares? We know that all sides are equal. So this is x, this is x, this is x, that's x. Okay? So area means length times width, or side times side. In this case, x times x equals 81. Okay? Because when x equals the length of one side, I always define the variable. Okay, so x squared equals 81. This is not in standard form. So subtract your 81, you get x squared minus 81 equals 0. This is the difference of a perfect square. My a term is x, and my b term is 9. So this factors to x plus 9 times x minus 9 equals 0. So x plus 9 equals 0. X minus 9 equals 0. So x can equal negative 9 or x can equal 9. But yet again, I can't have a negative length for the side of a square, so the negative 9 goes away. So the side of the square has got to be 9 feet. Okay? And there you have it. Solving quadratic equations with word problems is not that complicated. It just is a matter of setting them up. Once you have them set up, it's a matter of factoring them and then solving them and then making sure your solution fits the question that's asked. If it's asking for a side length and you get a negative number, that can't possibly happen. If it asks for positive, even integers, or you get an odd integer, or you get a negative integer, then it wouldn't happen either. So pay attention to what the question is asking to make sure that your final solution is correct.